And then lastly, with numerical data, you need to know normal distribution. I'll touch on this quite briefly, but normal distribution is essentially where your mean equals your median equals your mode. It's used for numerical continuous data. And you have 50% of your data either side of it. So it's like a perfect symmetrical piece of data. And it approaches zero on both ends. Now, normal distribution is really cool because it's utilized for your ATARs. So we normally distribute around a mean median mode of 30. And then we sort of distribute from there, and then scaling is very different to that. Don't worry about scaling. But the best way to describe the spread of data is through your mean, and then your standard deviation. So your standard deviation is just a value that is calculated in your calculator, and you don't need to worry how to do that. You just have to do it in your calculator, and you do that through your sheets. Most of the time, will actually just be given to you. But in a question, you're told, all right, my mean is 5, my standard deviation is 2. What would it mean? What value would I be if I was 1 standard deviation above the mean? Well, you go 5 plus 2. What if I was 2 standard deviations above? Well, you go 5 plus 2 plus 2. What if I was 1 below? 5 take 2, etc. And the reason we do that is because then we can sort of say what percentage of, if it was a mark, maybe it's a mark from an exam or a SAC, what percentage of your class are you ahead of? If I do a mean and a standard deviation of my class's scores, and let's say it's normally distributed, we normally distribute it, we can say, all right, what percentage of my class am I above? Well, if I'm 1 standard deviation above, I'm above, 50%, so 50% on this side, plus 34, I'm above 84% of my class. If I am 2 standard deviations above, well, 84 plus this 13.5, well, I'm now 97.5% of my class is below me, etc. And what's really important is you need to know these 3 lines and this exact diagram. This exact diagram must be in your summary book, full stop. This whole page needs to be in your summary book. I don't want you to screenshot this exact page and put it in. I want you to have this exact diagram screenshotted in, and then I want you to write out the other parts. Really important, you must have this information in your summary book, found reference. Doesn't matter if you don't want it there, it needs to be there. And why it needs to be there is because you get asked questions like this. A class of 24 students receives their science test results with a mean of 32 and a standard deviation of 2. How many students received a mark between 28 and 32? Well, how do I know how to answer this? Well, I go back to this diagram here. What did it say? It said I had a mean of 32 and a standard deviation of 2. Well, a standard deviation 1 below is 30 and a standard deviation 2 below is 28. So 2 standard deviations below is 28. So I'm going to be somewhere over here in between my purple and my blue. And then on the mean was the other value, is going to be just over here. So what I need to do is add these 2 together. So I need to say, all right, I have 34 plus 13.5. So what I'm saying is there is 47.5% of my class between those values. And I was told there was 24 students. Well, then I need to find 47.5% of those students and round to the nearest student, because I'm not going to say I have half a student. Half a student doesn't exist. I need a whole number. So as you can see here, 32 take 28 was 4. 4 divided by 2 was 2. So I have 2 standard deviations under the mean. So I need to add those 2 little areas. 34 plus 13.5, 47.5. So then I multiply that percentage as a decimal by 24. I get 11.4. Cannot have 11.4 students. Because it's less than 0.5, I round down. So I've rounded down to 11 students. Really important that you do that. Please make sure you don't round. Make sure you don't leave your answer as 11.4 students. There's not 11.4 students. You need to use common sense in these questions and say, all right, it's not a point. And then we have our Z-scores. So our Z-scores are essentially a little bit different. So we've done that first question, but then it says Ben achieved a result of 35. What is his standardized score? Well, a standardized score, as you can see here, well, actually this first question we haven't done. This is between 28 and 34. You're welcome to do that yourself. So, but your Z-score is a little bit different. Ben achieved a result of 35. What is your standardized score? Well, a standardized score is essentially your Z-score. So you would put it in this formula here. So your actual score was 35. So my X would be 35. So I'd be putting X equals 35 in my calculator. So that's 35. Then I would go to my x bar. Now, x bar is your mean. So I do 35, take 32. So 3 would go on top. And then I go to my standard deviation. Well, my standard deviation is 2. So I put 2 underneath. So I put 3 over 2 in my calculator. I'm going to get an answer of 1.5. So, as you can see here, then you also have this first question, which is an extension of that question we did before. I'm going to give you your time. I want you to have a go at that first question if you want. We're not going to go through it, but you're welcome to pause and have a go. You're back. But as you can see here, the answer to the first question is 81.5, and the answer to the second question is 1.5. So that is what a Z-score is. So